In this section, we're going to look at the discrete uniform distribution. This is a discrete random variable where the probabilities are the same for all values of x in a given range. So for example, suppose we have a discrete random variable x where the probability is k for all values of x, 1, 2, 3 and so on up to a certain value n, and it's 0 for any other value of x. So we want to know what the probability k would be. So because we know that there are n different values of x and they all have to have the same probability, and that probability has to add up to 1, we know the probability must be 1 over n. So for example, if this was 1, 2, 3, 4, 5, 6, 7, 8, 9 and 10, the probability of each x value would be 1/10. So this is called the discrete uniform distribution. All of the outcomes in this set, so all of the x values 1, 2, 3 up to n, all have an equally likely probability of occurring. We're going to consider the mean and variance of x for the discrete uniform distribution. So we have this probability function here. We know the mean is the expected value, and this is calculated by calculating the sum of each x value multiplied by its probability. So this would be the sum of each x multiplied by 1 over n, because they all have the same probability, 1 over n. Now because 1 over n is a constant, we can bring that to the front of the summation here. So we have 1 over n multiplied by the sum of all of the x values. Now we have a formula that we've seen previously for the sum of the first n integers, 1, 2, 3, 4 up to n, and that is a half n plus 1. So if we sub this in, we get 1 over n multiplied by a half n plus 1. This 1 over n here cancels with the n there, leaving us with a mean of a half n plus 1. So the mean for a discrete uniform distribution is half n plus 1, where n is the number of x values in this list 1 to n. We're now going to find the variance using the variance formula. So we know the variance is the sum of each of the x's squared multiplied by the probability minus and then the expected value of x all squared. So this is sigma x squared minus sigma x all squared. So we know that each of the probabilities are 1 over n. So because this is a constant, we can bring this to the front. And we already know that this in here is the expected value of x, which we calculated previously as a half n plus 1. So we can put that in here and square it. So we now have this formula here. Now we know from summations that the sum of, well, we know a formula for the sum of r squared. This is the sum of x squared, but this is the same thing given that x is the variable we're using here. So the sum of x squared is going to be the formula which we've used in summations. It's going to be a sixth n plus 1 to n plus 1. So we have 1 over n multiplied by that summation there, minus, if we square this, this becomes a quarter n plus 1 squared. We can simplify this a bit. We can cancel the 1 over n here with this n. We can pull out a factor of n plus 1. Having pulled out the factor of n plus 1, we can also bring out a factor of 1 over 24 because that is the lowest common multiple of 6 and 4. By pulling out a factor of 1 over 24, we are essentially multiplying this term here by 24 and this term here by 24. So we get 1 over 24 n plus 1, and then 4 times 2n plus 1 minus 6 times n plus 1. So just expanding that out gives us this, which simplifies down. We can simplify this a little bit further by pulling out a factor of 2 from this bracket here and putting it with the 1 over 24. So that leads us to 1 over 12 n plus 1 n minus 1. So that is the variance of a uniform distribution with x values going from 1 to n. So in summary, if we have a discrete uniform distribution defined as follows. We have these formulas for the mean and the variance. So pause the slide now and think about how you would find the mean and the variance for the value on a fair 8-sided dice. So we know that this would have a probability distribution where the probability of x being x is for x values 1 through to 8, the probability will be an eighth because there are 8 sides on this dice. It will be 0 for any other value apart from 1 to 8. So we can now find the expected value of x, which we know using the formula, a half n plus 1, will be a half of 8 plus 1. So the expected value, or the mean value on this dice, will be 4.5. The variance, we can use the formula a 12 n plus 1 n minus 1. So the variance will be 5.25. Now complete exercise 1C on page 262.